Good afternoon, everyone. My name is Robert Bond.
And I'm John Haber.
And we're from Analytical and Combustion Systems. Today we'll be presenting on boiler and generator fuel oil pumping and distribution systems.
Your local rep organization for all things fuel oil. After this presentation, we will have a live Q&A session. We will take your questions and hopefully answer them. Also, if you have a quick question you'd like answered during the presentation, you can send a question in through the chat box. Or if you are not in a hurry, you can email us as well. Robert, back to you.
In this portion of the presentation, we'll be handling fuel oil handling overview and systems. We'll begin with the fuel oil systems layout, and then we'll move on to pumping basics, specifically pump types, characteristics, and pump slip and issues you might have. Then we'll move on to fuel oil systems, application examples, emergency generator systems, along with boiler loop systems for fuel oil burners. Then we'll move on pump set selection, where we can talk about how you can size and select the appropriate pump for your application. Next is fuel system design, your control strategies, fuel oil specialties, and system piping, best practice, so you can have a solid system. And then the New York City caveats, which are also very important so you don't run into code issues. And then the last topic, which is becoming ever more important, is a long-term storage of fuel oil systems for your tanks and storing that oil.
So Robert, regarding strategy, I mean, there are a lot of different types of systems that require different types of strategy. This is kind of an overview more on the design of the pump skid, and we probably don't really deep dive into strategy as much as could, but so in the future, if you have questions on types of strategies, we can certainly elaborate further on that.
All right, on this slide, we're looking here at just a full fuel oil system layout. You see some underground storage tanks on the left. You see an above ground storage tank. There's a day tank up by the emergency generator. You got your fuel oil pump set on the lower right. And then, of course, you got your fill station out on the street there. And this is typical, again, for you got a generator loop and or a boiler loop.
Right, so typically you're not going to see all of them piped together like this because it can create control problems and surging in the system. But it's either, you might see a typical boiler loop with this equipment, or you may see a typical day tank system. And there are probably some valves in this system most engineers wouldn't see, like in a water system. Right, Robert?
Sure, yeah, absolutely. Sort of some important ones to point out quickly are number 10, there's the anti-siphon valve that's used for when your tank is located above the level of your pump set. That's very important to have. Another one that to point out is number 9, which is the tank selector valve. Comes in handy a lot of times when you've multiple tanks, and you can combine the supply, the return, all the important lines all in one valve, which makes it very nice for your maintenance worker. And then number 27 is another important one required by code. It's the Firematic lever gate safety valve. So that is, again, required by code and needed for the fuel oil systems.
That can have a switch on it as well, so if you wanted to monitor that, a lot of these generator systems are unmanned.
Right.
The job gets installed, the door gets closed and locked, and I hate to say that, forgotten, but the beauty of our control strategies is that we can have a pretty detailed monitoring system of the valves in the system. If it moves, we can monitor it.
Right, and that's, again, important, especially for an emergency generator system or boiler system where, when the lights go off, you need it to work right away. One of the most important terminologies when describing a fuel oil or designing a fuel oil system is the NPSHA, the net positive suction head available, which is a function of the system. So you as engineers have control over this regarding the valves, the fittings, the pressure drops through the system. It is, again, it's a function of the system. It's not, unlike chilled water systems where there are expansion tanks that pressurize the chilled water systems, a fuel oil system operates under a vacuum on the suction side of the pump. And then NPSHR, net positive suction head required, is a function of the pump itself. So the NPSHR is the minimum pressure required to keep the fluid in the pump from flashing or cavitating within the pump. In this slide, we're going to talk about the NPSH and cavitation. There's high velocity and low pressure at the suction side of the pump is going to cause the pump to cavitate, which will dramatically reduce the efficiency and damage the gears of the pump. The cavitation is going to start when the pressure in the liquid is reduced to the vapor pressure of the fluid at the actual temperature. So the NPSHA, which is designed, by you, the engineers, must always be greater than the NPSHR, which is again a function of the pump itself. And if that's the case, if you can keep that higher than the NPSHR, you're going to prevent this cavitating, which is not a good thing. It doesn't sound good, and you can tell there's definitely something wrong. I mean, John, have you heard?
I've heard pumps cavitate, and it gets pretty loud. It's sounds like there's some hammering going on inside that steel pump, and if it's making a lot of noise, people want to head for the door.
Yeah, and especially if you're at a high-end hotel, this is any excess noise is not appreciated.
True.
Here in this short video, we have a great representation of a spur gear pump, and you can see the little vortexes right after the gears unmesh, and you see that's actually the fluid flashing, and that can cause great cavitation to the pumps.
It's quite a unique video. Imagine this, pump after 10 hours of this happening.
Yeah, there's not going to be much left of your gears after a while. This slide here is a representation of your NPSH and cavitation entering the pump. You see at the very beginning, it's pretty steady, and then when that drop is when it enters into the gearing of the pump itself. And then at the far right end of the graph, there's your pump discharge. Again, just a representation of your NPSH, and it's very important to keep the suction of your pump high so that it doesn't drop below that vapor pressure line, where you will definitely create bubbles, aka your vortexes, which will cause cavitation. Why do we choose positive displacement pumps for fuel oil systems? Well, first of all, most practically, it's able to pump very viscous fluids. Then the positive displacement pumps are self-priming to a point. There is a time, and depending on your application, where you will have to prime the line. It is able to lift quite a bit of fuel on the suction side, and creates a relatively large suction on the suction side. The discharge flow is relatively constant over a range of operating pressures and viscosities. You don't have a crazy pump curve like you will on a lot of centrifugal pumps. And then you can develop high discharge pressures on the discharge side of the pump. So you need to be careful on the outlet of the pump and all throughout the piping system on the discharge line that there is never a blockage, otherwise something will break. So if you're looking at the flow and the pressure, it's important to remember that the pump flow is determined by the motor RPM, and that your system pressure is determined by your motor horsepower.
Right, and a code requirement in New York City is to have a safety relief valve piped back to the oil tank between any pump discharge and a shutoff valve.
Right, right.
And it's code requirement to have the positive displacement pump for the New York City market as well as international code.
I think.
Also, you cannot run these pumps dry. They are steel and will melt. What you don't usually see on these types of pumps are variable feed drives. When the pump runs, it's up to speed in a matter of seconds, and when it stops in just a few seconds.
This slide here is a great pump comparison between a positive displacement pump and a centrifugal pump. You can see on the performance chart here, the positive displacement pump has a constant flow regardless of the feet of head to a certain extent. Whereas the centrifugal pump, you can see the head decreases as you increase the flow rate. On the flow rate portion of if you look on the right portion of this slide, you can see that the flow rate versus the viscosity in the positive displacement pump, the flow rate actually increases as you increase the viscosity of the fluid, whereas the centrifugal is actually the exact opposite. It decreases when you go to a more viscous fluid. Example of this is a positive displacement pump always will pump more 6 oil than it will number 2 oil, and that is simply due to the viscosity of the fluids. If you look on the bottom left portion of the slide, you can see the efficiency. The efficiency percentage versus the feet of head. For a centrifugal pump, this is where pump selection becomes kind of tricky in chilled water systems when you're dealing with centrifugal pumps, as you always want to hit that peak portion of the pump efficiency. And whereas with a positive displacement pump, you really don't need to worry about that. So when you ask us for pump curves, unfortunately we can't give you curves. We'll be able to give you pump lines. As you can see, the flow rate increases with the speed or RPM of the pump. There isn't any change really, it's just a constant line.
This slide is in reference to pump inlet suction guidelines. Getting the oil into the pump is the hard part. The positive displacement pumps will positively pump the oil to the destination. Best practice is to keep the pumps as close to the tank as possible. Try to avoid excessive suction lengths and inversions. Suction pipe sizing is critical when sizing. Quality positive displacement pumps will create 20 inches of vacuum. We like to design systems with a pump vacuum with less than 15 inches mercury. As a rule of thumb, pumps will work for buried tanks with a max lift of 20 feet from the tank bottom to the pump inlet. Although code calls for a pressure test on the piping, we also recommend a vacuum test on the suction side of the piping. Determining inlet suction. Determine gravity head in feet of oil. Figure the lift from the bottom of the tank to the pump inlet. Convert your fittings, your valves, your length of pipes. Add your losses through the strainer. And by the way, we like to size our strainers at a 1/2 inch mercury pressure drop through a clean basket. If your losses are too high, increase your diameter. And pay close attention to the suction line sizing, number of fittings, routing. Do not oversize, and what I mean is sometimes you get too conservative and you increase your pipe diameter, and if you have a very low pump flow rate and perhaps you have a buried tank, sometimes it's nearly impossible to pull a prime out of that tank if you have a 100-gallon-an-hour pump using a 4-inch suction line that has a dozen elbows and the tank is buried 3 feet below grade. Types of pumps we use in the industry, they're all positive displacement type as required by code. The first is the internal gear pump. We typically recommend for smaller systems. Our range of use is 20 gallons an hour to 1,000 gallons an hour with discharge pressures up to 100 psi. Spur gear pumps we typically recommend for medium range systems, 200 gallons an hour to 30 GPM with pressures up to 300 psi. And then we have a rotary screw type pump we typically recommend for large central heating plants, data centers, hospitals, anything high end. That range of 20 GPM, 280 GPM, and up to 500 psi. Fuel oil systems applications. We have fuel oil boiler loops at high or low pressure. We have generator systems utilizing remote day tanks or belly tanks or headers. Most common duplex pump skids will have 100% redundancy. Other types of systems are triplex pump skids or jockey pumps, where there may be a farm tank of oil, tanks, and they like to move the oil around. There are return pumps, and there are filtration systems with oil pumps. And one caveat is regarding day tank return pumps, not allowed for use in New York City.
For boiler supply loop systems, most burners have a supply and return line. Occasionally you'll run into the industrial sized burners and boilers. There aren't too many of them in the city, but occasionally you can run across them, and those won't have a return line. It'll just be a boiler loop. And the burners themselves will have a supply line directly, which will be regulated by a control valve and pressure regulator. But for your typical burner boiler setup in New York City, you will just have each burner will have a supply and a return line. Burner pumps need more oil than they burn. So a 5-gallon-an-hour burner might have a pump that requires 45 gallons an hour at the burner, and a 100-gallon-an-hour burner might have a pump next to it that requires 150 gallons an hour for your pump set to supply to it. Burners can be piped in parallel or series. It's very important to know the difference and the requirements that come with each. We'll talk about that later on. The pump set needs to flood the burner loop. So if you have a multi-boiler system and you have the piping potentially running across the ceiling, which is typical in New York City, you need to have the piping pitched back towards the burners and boilers, and also at the end of the loop when you're going to return back to the tank, it's important to either have a back pressure regulator or a vertical, possibly 6-inch, 12-inch vertical before you return back to the pump, so that gravity can backfill and pressurize that loop only to about 3 psi or so is the requirement by NFPA. In this slide, we're looking at a low pressure boiler loop. As you can see, we have the tank pulling, we got the pump set pulling the oil out of the tank, and then supplying oil to the two burners, both of which have a burn rate of 100 gallons an hour and have integral burner side pumps of requiring 250 gallons an hour each. So we're just going to go over the sizing really quick of how we recommend doing this. As you can see, the supply and return, as you can see, the return lines of the burner are returning back to the supply line itself, as it's just a simple boiler loop. So to size this properly, we would look at the pump set and look at the burn rate of the first burner and then the pump rate of the second burner to ensure that that last burner in line gets the necessary fuel oil for that pump so it doesn't cavitate like we talked about earlier. So that would be 100 gallons an hour plus the 250. We get a 350 gallon an hour minimum. It's then recommended that you put a safety factor of 1.5 to 2 gallons an hour for that, and so we would recommend a 225 to 700 gallon an hour range for the size of the pump set. And then just a quick mention about the piping. We highly recommend putting an inverted U at the very end of the boiler loop before you come back to the tank to ensure that all the air gets out of the fuel oil line and then will be pushed back to the tank where it will then be vented to atmosphere. Another good thing about the inverted U, besides getting the air out, is that it also keeps a back pressure on the boiler loop so that each burner will be getting the oil that it needs. According to NFPA, you need to make sure that pressure in the loop never gets above 3 psi.
It's a lowest cost option to a back pressure regulating valve, and it won't break.
In this slide, we're depicting a high pressure boiler loop. You have your pump set, you have your 2 burners. Each burner burns 100 gallons an hour. There is no burner side pump, as these burners are either pressure atomized or they could be air or steam atomized at the nozzle. So you don't need to worry about any pump rate at the burner. You just need to look at the burn rate. So you got your 100 gallons an hour plus burner number 2 at 100 gallons an hour for a total of 200. So then you use your multiplier, a safety factor of 1.5 to 2 to come up with a recommended 300 to 400 gallons an hour for this example. Something else to point out is the back pressure regulating valve after the last boiler to keep that loop pressurized. Normally, if you're firing number 2 oil, you need at least 60 to 80 psi of oil pressure for that atomization. Sometimes it can go much higher if you're using a pressure atomized nozzle on those burners. But again, this is a high pressure loop typical of industrial sized applications.
Right, so interesting scenario. The duplex pump skid, in essence, is really creating the pressure at the nozzle on the burner for firing.
Right.
And the back pressure regulating valve is what you set at the pressure at.
Right. It's not the burner side pump that's creating the necessary pressure for atomization. It is the loop itself.
Day tanks. Day tanks are used for emergency generators, boilers, and other fuel burning devices. Used for remote limited supply at fuel burning device and decouples the appliance pump from the main transfer pump on the bottom floor. We recommend a 2 to 4 hour storage at the remote device. Use drop tubes to prevent foaming problems. The return pipe can be extended at least half the distance to the bottom of the tank. For good circulation space, supply and return piping as far apart as possible, each near the bottom of the tank. And you must have a means to prevent overfilling. Day tank piping considerations. System design determined by either generator consumption or pump flow rate. Similar to boilers, there could be a large difference between the generator burn rate versus actual pumping rate. A good rule of thumb is each 100 kW of generator capacity will consume 7 gallons per hour. Generators that are piped with return line back to the day tank require a smaller flow rate as the transfer pump set is sized for consumption. Generators with return piped directly back to the main tank require larger transfer pumps. Try to avoid small day tanks on large generators as the recirculated return oil could overheat the small day tank. Note the flash point of diesel oil is approximately 138 degrees Fahrenheit, and generators typically have a shutdown sensor at between 140 and 150 degrees Fahrenheit. Remedies for keeping day tank supply fuel oil cool. Install a fuel oil cooling radiator to prevent overheating. Return directly to the main tank, bypassing the day tank. Or if possible, increase your day tank capacity. Then you determine your duty cycle of the pump set. Typically, on taller buildings, the rule of thumb is 4-to-1. And this could be buildings at 30 stories up. Sometimes with 3 or 4 or 10-story buildings, you may only use a duty factor of 3-to-1.
So John, how long has that 7 gallon an hour per 100 kW rule been around?
The 7-gallon rule per 100 kW has been around since I started in the mid-90s, so it's been around a lot longer. It's a representation of a typical New York City generator installation. The main oil tank is in the basement with the pump skid, and the day tank is located up at the generator on the upper level. This shows the generator return line piped back to the day tank. Therefore, the pump skid will be sized for consumption. The static head and piping losses will determine the discharge pressure of the pump skid. The overflow pipe per code must be 2 standard pipe sizes larger than the supply pipe. The maximum storage per floor above the lowest floor of a building in New York City is 330 gallons. And the roof is considered a floor of the building. The day tank must be vented locally to atmosphere, and you can install a T in the vent line and connect that line to the overflow line going back to the basement tank. We also recommend a switch in that vent line just in case the oil is going up that line. You'd like to know that's an issue. Be sure to keep supply and return lines as far apart as possible on tanks. For main tanks and day tanks, when the vent pipe is extended a long distance, you must be careful not to exceed the pressure rating on that oil tank. For flood zone buildings, refer to Appendix G of the New York City Building Code for your storage limitations. And UL 142 rated tanks are maximum 5 psi static pressure rated. However, the New York City alternate tank design is rated for 25 psi minimum. The New York City tank design allows the vent lines to be extended further and higher in elevation. This higher pressure rated tank must be used for installations with vent lines above 12 feet vertical or over 20 feet horizontal. So it's difficult in selecting, there's some difficulty in selecting the day tank and meeting the pressure requirement for the job, which is based on the back pressure from the run of the vent line.
So that's how you decide whether you're going with the UL 142
Right,
or a
or
New York
if you
City
need
approved.
New York City, that's correct.
And that applies for day tanks or main tanks?
Either one. You're going to have the same effect on the vent line for either tank. And now there's that Bulletin 2018-10, which gives you the 4 piping configurations for day tanks in New York City. This is a typical UL 142 belly tank and includes a working vent on the primary portion of the belly tank, 1 emergency vent on the primary, and 1 emergency vent on the basin side. All vent lines are combined and run to atmosphere. Note the overflow piped into the vent. Vent line is sized for vapor flow, overflow sized based on oil pump flow rate. Day tank controls. Day tanks inside buildings can include an open top rupture basin for containment. Day tank level control consists of a multi-point level switch, pump on, pump off, with high and low level set points. As you see in the cutout, our low point is approximately 40% day tank capacity. This allows the facility some time to respond to the low level alarm. Tank basin will include a leak detection switch. Pump supply and overflow connections shall include drop tube connections in the tank to prohibit foaming. FYI, the device with the red cap is the weighted emergency vent. These are illegal for use and installation in New York City.
So, John, for a New York City approved tank, we wouldn't need that weighted emergency vent. We'd be able to combine all the vents, correct?
Yes, yeah. So a New York City tank is 25 psi rated, which allows you to only require the working vent, the smaller vent on the tank, and then you would size your vent running outdoors if it's an indoor tank, and size your pipe accordingly to keep the pressure under the threshold of 25 psi. Same holds true for UL tanks. So you're going to have a 5 psi rated UL day tank that would have a fitting on it, the large fitting. You're going to combine your vent lines to match that larger fitting, and then the vent itself, the line itself, has to be sized according to the run, and keep the back pressure on that day tank below the 5 psi.
Right, right.
Generators with a header system. Header is for use when day tanks are not practical. They are sized same as day tanks with a maximum allowable capacity of 330 gallons. This slide represents a header system that is required for outdoor installations. Indoor installations can use a single wall pipe with a containment basin. And your maximum supply pipe feeding this header is 4 inches in diameter. You will include leak detection, a foot valve for generator suction, and recommend a low-level sensor as a backup. As you can see, there is a vacuum breaker in the return line piped to a drum. This drum will include a breather and a leak sensor. We recommend the inlet supply pipe and the return pipe be at opposite ends of the header so you can get full flow through the header.
So, John, is there any code requirement regarding that low-level sensor?
It's not really code required, but it's safe practice, I would say, for these types of installations, because if the generator fails to send the start signal to the pump panel, you won't know the generator's out of fuel until it stalls out. This is allowable per the New York City DOB.
In this slide, we're going to talk about the long-term storage of fuel oil systems and the special considerations that come with that. With diesel fuel oil, it's important to remember that it is an organic compound that does decay over time. And again, now that diesel is being combined with even more biofuels, B10, B15, B20, it becomes even more of an organic compound and critical to have a fuel oil filtration and polishing system when you have a large storage tank in case of emergencies. So emergency generator fuel oil can be stored for up to 10 years. Diesel fuel is prone to degradation as the moisture accumulates in the fuel, which will corrode the injectors on the generators, and it will seize valves. The bacteria likes to grow in between the oil and the water interface, which will again clog filters and injectors in the generator when you really need that emergency generator. The fuel also oxidizes, and the cetane rating drops in the fuel, so not good stuff at all. The fuel can degrade beyond the point of use in just 5 years. Proper maintenance and stored fuel definitely extends the life of the fuel and keeps you ready to go at a moment's notice when that emergency generator or boiler loop needs to kick on. It's important to remember that you need to turn over your fuel oil annually, is what most generator manufacturers recommend. They even recommend it more than that, but that would be the bare minimum. The reality is most oil does not get turned over by the end users. So having a polishing and filtration system that does automatically turn over the fuel oil and keeps it ready to go is highly recommended. This slide is a perfect representation of what we were talking about in the previous slide, just showing your fuel oil tank with your oil, your water, and again that bacteria layer that likes to grow in between. This is any tank that is vented to atmosphere has the potential to grow this bacteria. Monthly generator tests will not consume enough fuel to keep the fuel oil fresh and turned over, and that's monthly. Again, most tanks are not overturned within a month, so it's very important to keep things ready to go for your emergency generator systems. The sludge grows at the fuel-water boundary at the bottom of the tank. We highly recommend putting a supply and return line for your filtration system. These are dedicated supply and return lines at the opposite ends of the tank to ensure that all of the fuel oil in the tank is being filtered and processed and dewatered. Filtration supply and drop tubes should drop lower in the tank than the normal supply line for your pump set in order to pick up that water and sludge so we can dewater the tank and get that junk out of there. Again, each generator has a 10 micron filter at the generator itself, and that's very small, so any of this bacteria or sludge that gets picked up in your fuel oil pump set and sent to your generator will get caught in the 10 micron filter and will shut your generator down. Filtration system prevents this and filters the fuel oil down to 5 micron. Another thing to note about the water in the bottom of the tank, if that is allowed to sit for a long period of time, does not bode well for these steel tanks that are put in everywhere. Another thing to mention is that the ULSD, ultra low sulfur diesel, are even worse for steel tanks. So if you let that water sit at the bottom of your tank for a long period of time, it's going to erode the tank and allow for premature failure. Here we have a picture of a typical fuel oil filtration unit that can be freestanding. It has a small footprint, can fit in pretty tight spaces in your fuel oil room or in a dedicated room for it. This has a integral leak detector in it. It will filter the sludge and water and in the oil down to 5 micron before returning it to your tanks. This can be used for single tank or multi-tank applications, and the inventory in your tanks determines the system design for your filtration. On this next slide here, we have a skid-mounted fuel oil filtration system. This is for your larger applications, a couple large tanks. Again, we can filter down to 5 micron, get your water and sludge removal out. It can also do chemical treatment, automatic PLC controls for automatically sequencing your filtration system when your units are down and your tanks are just sitting for a certain period of time. This will double the fuel life in your tanks. Your generator's engine will start reliably. Again, it can sequence through your tanks in a multi-tank situation. And then again, these are sized based on your oil capacity in your tanks. This is our fuel oil sizing program that we used in helping engineers design their fuel oil systems. Here we have a typical day tank or main tank that is slightly above our pump set, so that's why we have an anti-siphon valve here. And then we can size your filter on the inlet of the pump. We are able to size your suction piping, your supply piping, and what the pressure is needed at the end of your system. Depending on how many floors up you go for a generator system or a boiler loop. Regardless, we're able to handle that all in the program, and then we are able to give you a nice printout. On this printout here, you can see we used a 2-inch primary suction line. We're able to put in the temperature, viscosity, all that detail in for you, and then we can calculate out the friction loss in the piping, the fittings, the anti-siphon valve, all those friction losses, which are very important in designing the piping system for the pump set. As you can see, the pump suction here is 14 and a quarter inches of mercury. And then, so that's what your pump has to suction out of the tank. We also show your NPSHA available and your NPSHR, like we talked about previously. We also can show you the velocity that you will be pulling the oil out of the tank with. We also went with a 2-inch discharge line. We also, again, are able to show you your velocity for your discharge, along with the pump pressure, and that is going to be the back pressure pushing back on your pump at the discharge line. So depending on how many floors you go up, you have all that head of oil pushing back down onto your pump. This is again very important when sizing.
Oh, Robert, one thing, we'll get a lot of return questions on is what's the pipe diameter for the return line? How do you size that?
So the great thing with this is you're able to size your supply line up to your generator, and once you have the proper size for that, going back and referencing the code, you would need 2 pipe diameters larger than your supply line. So we have a 2-inch here, which would mean that your return line would need to be a 3-inch back down to your tank.
And that's a typical scenario, but I think, if you have a situation where you're running an overflow back across a building that's a block size, you might want to take a closer look at that, run a pipe and make sure the diameter is going to be able to feed that velocity.
Right. So here we have a typical fuel oil system for a generator on a different floor. You got your fill, your tank, and then you got your emergency generator up on the roof with a day tank nearby it. These pump sets can be as simple as a hand-off auto switch on the pump set, or it can be as complicated as a PLC system. The great thing about a PLC system is that it does talk to the building management system, and it's definitely a trend in systems today is to be able to talk to the building management system, or a cloud-based system which can send notifications, text messages, phone calls, emails to your maintenance department, so that you're getting a call from your cloud or your building management system as opposed to an angry tenant. These are our typical shutdown conditions that you can see here. The ones with asterisks are New York City code requirements, which are important to pay attention to.
New York City fuel oil code caveats. For day tanks above the lowest floor, you must have 200% containment. Your maximum is 330 gallons of storage per floor. UL 142 tanks requires both the operating and emergency vent lines terminated outdoors. New York City alternate tank design, 25 psi G rated tank, requires its operating vent be terminated outdoors. Also, the New York City alternate tank design tank does not require an emergency vent. 1 day tank per pump set. Tanks debasement over 660 gallons requires a means of spill containment at the fill box. All basement tanks are in a 2-hour fire rated room minimum. Riser pipe requires leak detection with pump shutdown logic. Anti-siphon valves are used on tanks when the inventory is above the pump inlet. A foot valve is required when the tank inventory is below the pump inlet. You'll have a leak in the riser piping monitored with a drum. Fire valves are provided on the pump suction line and the inlet to the generator room and all fuel burning devices. Some parting rules of thumb. Thanks everyone for tuning in. Robert, great job.
You too, John. And now we're going to take some questions in the chat. And if you would like to send us a question over email, you can do that as well. And our emails are on the screen. And thank you all for coming.
I'm here with John and Robert, and we're just going to take a couple questions. All right, first question we have here, we had some technical questions. Let's see what we got. So a question we have is there no vent in the header system?
That's correct. There is no vent in the header system. It is not a tank. It's considered a header or reservoir is another term used.
Great. So another question that we have, how can a positive displacement pump lift both lift and vacuum but not be run dry? Isn't the vacuum dry? Please clarify. So I'll read the question one more time.
So the vacuum is the lift pulling it up out of a buried tank or pulling it through piping. So the lift is simply the inches of vacuum created to pull the oil into the pump.
Right.
So you want to elaborate on that?
Yeah, no, I mean, I think you said it just fine. It's just, you're not, oil's not being pushed into the suction side of the pump. It's being drawn up out of the tank, therefore, creating a small vacuum on the suction side of the pump.
What we've seen on occasion is sometimes if you do lose vacuum, your lift will skyrocket in inches. So you might pin your vacuum gauge and you'll know there that you're probably pulling air into the system. But a typical working system would be between 7 and 15 inches of vacuum mercury.
And I think he was asking, why can't you run it while it's dry? And I think the reason because of that is because you have metal on metal contact and it will literally melt itself because it doesn't have a coolant, right?
They are steel geared pumps, so they can heat up and experience some degradation in the pump.
Do you want to clarify real quick why we use steel and not any other materials?
Primarily steel is used because it's a durable pump required for these types of installations. That's our preferred type of pump. I know there are brass pumps, but if you get any pieces of steel from the system into the brass pump, it'll destroy the brass gears pretty quick.
Great, thank you. Let's answer a couple more questions. Looks like you have some here. Is the pipe header in the diagram installed at a lower elevation than the generator? So because we had it illustrated like that, and the other one, the second part is there a distance limit that the generator can draw from?
Generator projects that have a header, the header is typically near the generator. It could be a couple of feet below it, but I wouldn't really go much farther than that because there are limitations on the vacuum capabilities of the engine manufacturer's supplied pump.
Right, so you'd really have to look at what the generator side pump, you'd have to look at those specs as far as what that can pull and how far and what, so sort of the same situation that we'd run through with a duplex pump set in the system. You need to look at the distances, the head, the suction that it can pull.
Right, and even I would recommend a header on jobs where the generator is in the basement and your tank is in the basement. That way you can install this system and not have a day tank where you'll have venting issues or overflow issues. You can have your header at the elevation of the injectors on the generator and be able to circulate that from the tank back to the tank with minimal problems.
Excellent. A few more here. We have why the requirement in New York City for fuel pipe risers to be enclosed in a masonry enclosure and for the pipe to be 4 inches from the interior of the wall of that mason air enclosure. Not sure if you're-
Single wall pipes running up risers, the oil carrier pipes in the buildings. The 4-inch masonry is for your fire rating. And the spacing is a conservative design for pipe flex.
One other question, looks like we have one other about the header system. So what's the purpose of the drum in the header system?
So if you have a header system installed and you include a vacuum breaker, code requires that vacuum breaker to go into a collection source, which is typically this drum. What we do is pipe the header, the vent vacuum breaker into the drum. If there's any kind of backspill, it has to drain somewhere, and that would be the drum. And then we have a breather on the drum, so when pump stops filling the header, there's still oil in the return line falling down the building. And if with the pump off and the oil still falling down the return line, that could create a vacuum.
Mm-hmm.
So what we do is we'll pull air through the breather on the drum and break that siphoning effect on the header.
Right. Great. We have many, many more questions. We're not going to be able to get to all of them, but let's just keep going. Can number 2 oil be utilized for emergency generators?
Yes. Yeah. I mean, those are the two most common, right? They're natural gas and they're also number 2 fuel oil.
Right. Diesel oil and number 2 fuel oil are practically the same specific gravity.
Oh, right.
All right. Next one, can a single number 2 oil storage tank in New York City be used to supply fuel to a boiler as well as an emergency generator?
It can. It's not recommended to have both a generator system and a boiler system on the same loop, because let's say hypothetically you're running your boilers, need those boilers to stay on, but then your emergency generator has to kick on. You might run into issues of suction issues as far as the burner side pumps on the boilers, pull, all of a sudden they kick on and they start pulling. So I would pay very careful attention to the piping, but yes, you can do that.
Great. Let's do another easy one. Is number 6 oil still an approved fuel source for use in New York City?
I believe as of 2020, it is not. Now and I think number 4, there's a time limit on number 4 oil as well. I think it's 2030. Yep, 2030.
Great. So we have a question about how an anti-side valve works. Without going into hours of explanation, can someone just talk about, in a general brief overview, how it works, and then what's the difference between getting a electrical one with a actuator on it versus a mechanical one?
Sorry, go ahead, John.
It's a puppeted device, and there's a spring that creates pressure, resistive pressure on the poppet. When the pump is creating the vacuum, it needs to have 6 to 15 inches of vacuum to lift that poppet and allow the oil to pass through. If the pipe were to break, there's no way a piping system could create that amount of vacuum to open that anti-siphon valve.
And just real quick, can you go over what's the difference between a mechanical one and an actuated one, and maybe some of the?
There is only really a mechanical anti-siphon valve. An automated electrical would probably be something in the line of a motorized ball valve, which you perhaps can use in place of an anti-siphon valve on special consideration jobs that
Like high flow.
have high flow or large tanks may be much higher than the pump on the system as well.
Mhm.
Okay, so another one is, in addition of pipes, with pipes, what other options we have in New York City for secondary containment of fuel when pipe risers need to have horizontal offsets?
So that's like piping pipe. We're talking double wall pipe in the riser. So you can either do the double wall pipe in the riser, or there's also Brugg piping, which we use pretty commonly in risers, which is a prefabricated double wall pipe that comes actually in a large coil. And contractors love this because you can just take it to the top and just drop it down the riser. No welding needed. You just have your connectors to your tank, and then up to either your generator or whatever you're connecting to at the top. And then you're good to go. That's Brugg piping, BRUGG. If you're curious about any of that, please feel free to reach out to myself or John. John, do you have anything else to say about that?
Right, so code is very specific. Anytime you use a single wall Schedule 40 piece of pipe, rigid pipe, you're gonna have to put that in a 10 gauge sleeve on a horizontal run. Also, you'll have to fire rate that per code. Now, Schedule 40 pipe can be single wall in the vertical riser, but once you start horizontal, you'll have to encase that in a 10 gauge sleeve, or use the alternate flexible Brugg pipe, which is already double wall, and run that from point to point.
And that also has a vacuum leak detection
As
built in.
opposed to the 55-gallon drum. So we have two
Right.
different types of pipe with two different types of leak monitoring systems.
Excellent. Let's just do two more real quick. Just two more questions. When lifting oil from a tank on the suction side of the pump, how does the anti-siphon valve distinguish between negative lift pressure and siphoning condition? And a lot of questions about the anti-siphon valve.
As mentioned, the anti-siphon valve requires a lot more lift to open it. A lot more than just a simple broken pipe would create if the suction line sheared off the strainer at the inlet to a duplex strainer.
Right.
So gravity pulling that oil through the anti-siphon valve isn't great enough to open it, as opposed to the vacuum you could create with a positive displacement pump.
If the tank is vented into the atmosphere, what's the reason for the tank to be rated at 5 psi or New York City 25 psi?
So the reason, UL 142 rated for 5 psi, New York City approved is 25 psi. So the reason is, if you have, let's say you have a UL 142 tank in the basement of the building, and let's say that something goes wrong in the fuel oil system, and that day tank begins filling up with fuel. It starts going up the vent. You're creating a back pressure on the day tank. And when it gets over 5 psi, obviously things are going to break. If you look at the New York City Code 1305.7.4, you're going to notice there are requirements for the head pressure for those tanks. So the New York City approved alternate design is, again, rated for 25 psi. It can handle that back pressure in the event that the vent on your day tank goes over 5 psi.
So a UL 142 tank, if your vent line is higher than 12 feet, you've surpassed the pressure rating on the UL tank, and you won't be able to use it.
There you go.
Anything in a sub basement, third sub basement below, you'll use your New York City alternate tank design. We have on occasion, and tanks, buildings with 5-6 floors below grade, used a 50 psi tank. So depending on what that head pressure on the tank could be from that height of that filled vent line will also determine your tank pressure.
Right, and we can, so it's important to do that calculation on, what back pressure you would put on your tank. And, we have a calculator for that as well. We'd be happy to help out with that. But yeah, and definitely an important thing to look into.
There are when you're sizing vent lines on these tanks too, on a UL tank, I mean, the vent line can grow in diameter quite large
Yeah, the main tank.
on the main
Right, yeah.
tanks, yes.
Excellent. So that's all the time we have for today. If your question did not get answered, I will do my best to share them or split them among Rob and John. If your question does not get answered, feel free to reach out to either of these guys. They're more willing to help you guys out with the systems and help designing it and helping make sure you navigate the New York City code, which is what I've heard forever changing.
Correct.
So John and Robert do their best to keep up to date with that. John, do you want to speak about your new material you have for the fuel oil series that you're going to hand out? Fuel Oil Demystified?
So we have a nice little sheet called the Fuel Oil Demystified, which kind of breaks out different types of piping for header systems versus boiler loops versus generators. Also kind of dabbles a little in the controls market and gives you information on oil tanks and typical characteristics. It's a nice little shortcut and some very good information. We'd love to send it to everybody. Feel free to reach out to us and we email this right over to you or mail out a hard copy.
Yeah. Okay, great. So like John said, feel free to reach out to them. And John, Rob, thank you so much for coming. It's great to have this. I thank you for coming, and we are out.